Hi everyone, in today's video we're going to discuss how to calculate CIDR notations. Oops, but first we're going to doodle some thing here. If we can doodle, like doodle. Alright, so let's calculate CIDRs. Okay, let's say for example we want to calculate 192 dot 168 dot maybe 1.0 slash 28. How do we calculate this? What are the IP addresses that will be generated on this CIDR block? But before that, we need to, maybe you want to know what is a CIDR block. So a CIDR block is a classless inner domain routing. It is a method for allocating IP addresses and routing IP packets efficiently. It replaces the older system based on IP address classes. The purpose of CIDR is to efficient IP address allocation. It avoids wasting IP addresses by allocating flexible subnetting. Example, instead of assigning a whole class C block /24 for just a few hosts, you can assign /28 or even /30. Number two, route aggregation. Helps reduce the size of routing tables by allowing multiple IP addresses to be grouped into a single routing entry. Number three, network design flexibility. You can create custom sized networks depending on your needs. CIDR notation explained. CIDR notations looks like this. So, for example, here it looks like this. So this portion here is what we call the network address. Network address. And then the /28 here is the prefix length, number of bits used for the network portion. That means this is the network, and the last 8 bits will be for the host. Maybe that is hard to understand for noobs like you, but it's going to be like this. IPv4. What is IPv4? Look it up. IPv4 is using 32 bits. And this thing here will be represented in bits. And this is 8-bit. So it's going to be like that. 1, 2, 3, 4, 5, 6, 7, 8. Then put a dot, another 8-bit here. Then put another dot. Oops. Another 8-bit. Another dot here. And the last 8-bit here. So this is your IP address in the machine's eyes. So this is a representation of 32 bits. So if you're going to count all of the yellow dots here, these are all 32. 8 times 4 is 32. So this means that we're going to use 28 of the 32 bits. So this portion here will be for the network. Look at that. And this last one is for the host. Okay, um, so we're going to calculate 192.168.1.0/28. We want to represent this into a binary. So 192, how can we represent this in binary? So let's see if we know how to calculate that in binary. Okay, 192. 192. Let's see if we can calculate this. Okay, 192 divided by 2. Okay, 192 divided by 2 is equals to 192 divided by 2 is 96. Thus, 96 has a remainder. No, it's 0. 96 divided by 2. 6 divided by 2 is 48. Does it have a remainder? No. 48 divided by 2 is 24. Any remainder? No. 24 divided by 2, 12. Remainder? No. 12 divided by 2, 6. Still no remainder. 6 divided by 2 was 3. Still no remainder. 3 divided by 2 was 1.5. So 1, the remainder is 1. 1 divided by 2 was 0. 0, and then remainder is 1. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So representing 192 is represented will be represented as, okay, 1 1 1 2 3 4 5 6. Okay, 2 1 1 2, then 6 0 0 0 0 0 0. So that is 192. Let's move on to the next one. Delete that. Sorry. Yeah, we just might need to erase that. Okay, 168. So 168. Let's calculate. 168 divided by 2. 68 divided by 2 is 84. No remainder. 84 divided by 2, 42. Still no remainder. 42 divided by 2, 21. No remainder. 21 divided by 2 is 10. Then 10 divided by 2 is 5. No remainder. 5 divided by 2 is 2. 1. 2 divided by 2. 2 divided by 2 is 1. No remainder. 1 divided by 2 was 0. 1. 1, 2, 3, 4, 5, 6, 7, 8. So 168 will be represented in binary as, let's put a dot here first, dot 1010, and then 1000. So that is 168. And let's remove this. Oops. Let's remove that. And let's put another dot here. So what is 1 in binary? So 1 divided by 2, 1 divided by 2 is 0. 1 divided by 2 is 0. So 1, and then 0 divided by 2 is 0. So it's all going to be 0 until 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be 1, 2, 3, 4, 5, 6, 7, 1. So that is 1. And obviously for 0, we're just gonna be 1, 2, 3, 4, 5, 6, 7, 8. All right. So next is, what we want to do is merge. All right. So next is we wanted to, this is the portion. This is the network portion here as stated, and this one here is the host. So nothing will be changed here, only this part here. So the starting point will be still this 192.168.1 dot, everything will be 0, so this is the starting point. And then the max range will be 000.1010.1000 dot 0000001 dot 11111111. So 1111 is 192.168.1.255. Okay, and the usable is 254. So it's going to be 192.168.1.1 until 192.168.1.254. So that is the usable IP addresses of this CIDR block. Oh, that's a long explanation, but that's it. And let's compute for a more difficult number. So for example, let's move here in a different area. Okay, so let's put a line here. Okay, so what if it's going to be a lot harder? So maybe 192.168.0.0 slash 10. So here it's slash 28, but now it's slash 10. So Again, let's just copy what we have here. 192.168.192 is 1, 2, 1, 2, 1, 2, 3, 4. Yep, that is the 192. 168 is dot 1010, then 1000, then dot 0.0. But now we are going to use only the first 10. So 8 plus 10. So this is the 8. So this is the network. And this one, this part here, will be the host. So 32 bits, 32 minus 10 is equals to 12. So if you're going to calculate this, 1, 2, oh, here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Why is it 14? Damn, hold on. 8, no. So, sorry. Should be 8 here, and then 8, 0 here. Okay, so 2, that is supposed to be 22, bro. Okay, 22 bits. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So 22 bits for our host and 10 bits for our network. All right. Now, what is the starting IP address here? So the starting is going to be 1, 2, 3, 4, 5, 6, 7, 8. This is for the 192.168 still. But then this one here would be 0, 0. We're going to start from the lowest, 0, 0, 0. Dot 0, 0, 0, 0, 0, 0, 0, 0, dot 0, 0, 0, 0, 0, 0, 0. So this is going to be still 192. Then the dot here. What is this in decimal? So how do we calculate that to convert that to decimal? Yeah, so to calculate that back to decimal, so we start from 1 here. 1 to the power of 1. So 1 here, so it's going to be 2 to the power of 7. This is the 7th position because this is going to be 7, 6, 5, 4, 3, 2, 1, 0. So 2 to the power of 7 is equals to 2 to the power of 7 is equals to 128. And then next is this one here, 0. 2 to the power of 6. So 2 to the power of 6 is equals to 64. 64 times 0 is 0. But so here is 128 times 1 equals to 128. Then for the remaining, because these are all zeros, this will all be just 0, 0, 0 here. So we say that this binary here is 128. and the remaining will just be 0, 0, 0, 0, 0, 192. And then what is the max range of this? So the max range would be 1, oops, 1, 2, 3, 4, 1, 2, 3, 4 dot. So the first 10, then max out 1, 2, 3, 4, 5, 2, 3, 4, 1, 2, 3, 4, 2, 3, 4, 1, 2, 3, 4. So we already knew that this is going to be 255. This is 255. This is 192. Now we want to know what is this. So applying our previous algorithm, that would be 1 here times 2 to the power of 7, which is 2 to the power of 7, 128. So this is 128. Then 0, 2 to the power of 6, 64 times 0. This is 128 here. 64 times 0, so 0. Another one here is 2 to the power of 5. 2 to the power of 5 times 1 equals 32. And another one here. 2 to the power of 4. 2 to the power of 4 is 16. 2 to the power of 3. To the power, oops. 2 to the power of 3 is 8. 2 to the power of 2. 2 to the power of 2 is 4. Then 2 to the power of 1 is 2. 2 to the power of 1 is 2. And then 2 to the power of 0. What is 2 to the power of 0? It's 1. 2 to the power of 1 is 2, yeah. So total is 128 plus 0 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, 191. So that is going to be 191 here. And so the range is so the answer is 192.128.0.0 or maybe 1 until 192.191.255.254. Okay, so let's check what is the range. What is the range of 192.168.0.0/24 CIDR block? Alright, so let's see if we have the correct answer. So, okay, so yeah, correct. Usable 192.128.0.1 until 192.191.255.254. And we have it uh, correctly calculated. And that's it. The total IP addresses would be um, 32 minus 10 is 22, 22 to the power of 22. 2 to the power of 22 is 4,194,304 IP address for this CIDR block here. All right, so that's it. Hope you like it, and I'll see you on the next videos. All right, cool. Thanks. Bye bye.